Okay, great. So good evening everyone. So my name is Agris Krusts. I am founder, so to say, of IT Centrs IT Security Consulting Company. I am doing IT security consulting and penetration testing from something like year 2000, so more than 25 years. So I've seen many things in our industry. So, and it's a good thing that it's always changing. So nowadays it's artificial intelligence or LLMs or what you call it. So I'm not going to talk very technically and not going to do some very sexy penetration testing stuff. Not going to talk about it, but basically going to talk about simple things about how you could use basic LLMs which are available online, or you can host them yourselves for day-to-day security monitoring and maybe pen testing data, not gathering but analysis. So that, basically my system is built with some couple of scripts and cloud code, but you can use any LLM most probably. I'm going to talk about what works, what doesn't work, and it's going to be something like 20 minutes, so I'm going to hope I'm going to be brief. And yes, so, and regarding IE, the problem is that everything is changing. So if I would talk about it a year ago, so probably I would not even imagine what comes today. So probably it's maybe relevant for a couple of months, maybe half a year, so after that there probably be different solutions. So if you look at security scanning and vulnerability scanning, or security monitoring in general, there are quite a lot of tools available, and data you are getting is quite big. So you can do Nessus scans, you can do open WAS scans, you can do Nmap scans, and there are logs from many sources. There are many Kali tools, so data is huge. And the problem is, if you do the automated scan with one of those tools, report usually is barely unusable. So it is full of all false positives. Probably there are some false negatives as well. So scanner thinks it's more or less okay, but it has very high security impact in particular environment. So other thing is that tools are very expensive. So if you look at scanner like Nessus, Nmap is free. So OpenWAS is free. Nessus is something starts from, I guess, 4,000 euros per year, and this is a cheapest scanner. So expert version is something like close to 8,000 euros per year, if I remember correctly, and there are other scanners which are in tens of thousands of euros per year. So, and all these tools have had steep learning curve. And basically, what I'm going to talk is applicable to pen test as well. So the data gathering and analysis, and so. So as you can see, we have the tools, but the problem is to understand what is worth your attention and what is not worth attention. So basically, triage. If you look at typical scan, I'm running scans quite regularly, depending on security risks. So it might be once a month or each week. Maybe some system. I don't think it's practical to run each day, but once a week is for internet-facing systems nowadays is kind of standard. So, but what you want to see is what's new, what matters, and what to do about it. So basically. And the problem is someone has to look at these scans and analyze them, create, for example, Jira tickets and stuff like that. So, and analysts are more or less expensive. So even junior analyst is kind of expensive guy just because of salary and trainings and stuff like that. So pen testers are even more expensive probably. And if my particular example I can show you later, so analyzing these scans, making Jira tickets, checking stuff, it's more or less full-time job for junior guys. So And speed matters as well, so if you can do it in hours or basically in days, it's okay. You can more or less could keep up with the stuff, especially today when I is discovering vulnerabilities. But if you are doing it very slowly, once a year or maybe once a quarter, so it's definitely true. Basically, you are missing many things, and there is a problem. So, and manual review can be very long as well. What artificial intelligence is good for? So it can read a lot of text. So basically, read scan reports and more or less not understand, but analyze them in text processing. So he could spot what changes. So what changes? So are there new vulnerabilities? Are there new systems? Are there new ports open? Stuff like that. So and it could filter out stuff which are not very relevant. So TLS warnings, so that you have some problems with TLS certificates, TLS configuration. So it should be fixed, but it's so low priority stuff. And if you have a lot of printers in the organization, so all the printers are generating these warnings, and so all your Windows desktops are generating these warnings. Everything is generating these warnings. So this is the task for artificial intelligence. So what it cannot do, so it definitely won't understand the security landscape of your organization. So for this security scanning, this is relevant for pen testing as well. So he could discover some problems. So some of the problems artificial intelligence is going to label as very critical, but in theory, in practice, it's kind of not very critical. But there are going to be some problems which are really critical, and it will be flagged as just informational findings, or he might not mention them at all. So this is a risk using AI basically without analyzing the output. So, and recently, actually, one of the recent pen tests where we used LLM for analysis of Docker containers, kind of missed very crucial stuff there. So it can found it, mention it in that kind of informational, but it's kind of critical stuff that we had to do intermediate report to the customer so that he could start fixing right away. So this kind of was, if you look at CVSS score, it kind of was problem with a score of 10.0. And it's goal-oriented. This is another problem. If you are looking for security vulnerabilities as defender, not as attacker, so and you are using LLM for it, it has a goal, find the vulnerability, right? But he can find it. But he probably won't find another vulnerability, so he's not going to go for all of them. So as for the attacker, it's kind of fine. So you find one vulnerability, attack your target, and everything is fine. So as a defender, you want to find everything. So recently was example, my colleague was kind of testing cloud code with Good Suite Professional for pen testing. So he asks, enumerate all the parameters for this query. He says, oh, there's just 2 parameters for this query. So he says, no, there are more, because obviously there are more parameters in work history. So, and he was kind of like very hard to convince this AI that there are more than 2 parameters. So how could you trust such tool in that regard? So probably you can find some vulnerabilities and it will be happy. So, but some might be missed. What else? Context. You cannot feed everything. So it's not possible, for example, to feed it all your data. So if you're going to feed all the Nessus report or Nessus file, it's going to consume your tokens. This is one thing, and it's going to run out of context very fast. So he might be confident about findings that I mentioned before, but you have to be very careful about it. So, and basically everything he produces should be checked by human. Questions so far? So based on that, so my daily monitoring setup, what I wanted to talk, it's kind of very trivial. It's I kind of was kind of on the fence talk about it, but actually when I talk with colleagues, not everyone is using such approach. Some of my security consulting colleagues or competitors are saying that artificial intelligence is crap and don't use it. Some are doing it manually. And so on. So one of my colleagues, for example, is doing bug bounties. He is one top 10 researcher in the top 10 in background ratings for researchers. So, and he told me that, for example, nowadays it's not possible to do bug bounties without artificial intelligence. If you do it manually, you are already late. So when the program is published, so everyone runs their IE tools and basically finds the vulnerability. So regarding this daily monitoring setup, so my infrastructure which I'm monitoring consists of a couple of thousand workstations and a couple of hundred servers. So quite large infrastructure. There is something internal and something external. So previously it was done by junior analysts. So basically almost full his working day was analyzing Nessus reports, make sure that Nessus is running, and create Jira tickets and verify that they are fixed. So pretty tedious job. And if you are creating Jira ticket, you have to somehow understand that is there a ticket for this particular issue which revealed in this latest scan. So it's not so obvious if you do it daily. So the Nessus scans whole infrastructure roughly once in a month. So basically each IP address gets scanned once in a month. Who is running Nessus scans in your organization? Okay, some are doing so. You probably know that you are not. It's a bad idea to tell the Nessus scan everything at once. So it's definitely going to fail because something won't work. So because of that, there are usually something like 3 nightly jobs with small networks. Then you will be able to scan all this stuff. If you are not doing that, so most probably the scan gonna fail, gonna stall, and you won't get any result. But it means that 3 weeks, 3 scans daily, quite a lot of scans to look through manually. And there is once a week scan for internet-facing resources. So basically, it scans internet IP addresses and internet hosts there. So. And the problem is, if you are doing scans once a month, even if you are updating Nessus regularly, you still have a 3-week gap about vulnerabilities which are published and your infrastructure. So this is the kind of problem. So yes, an output is, you can imagine that it's very hard to manage such output. So basically, let's Nessus runs daily scans. Yes, so how I approach this problem? So each day on the Nessus server there is a script which basically downloads Nessus report for the current day, converts it to Markdown. By converting it to Markdown, it filters out the unneeded stuff. So there are stuff which is not interesting. So basically leaves what is interesting. And if you are doing something like that, never do it by severity of how Nessus assigns the findings. So more or less you have to understand what you are looking for. So sometimes even informational or low-level findings are very crucial, and in reality they are kind of like risky. So you have to basically from experience understand what you want to filter out. Leave IP addresses, port numbers and stuff like that, so it's understandable. And then Mesos server copies it to staging server on internet, which is accessible to workstation where cloud runs. Cloud code never has access to infrastructure or Mesos server for that matter. So even if there is some informational leak or some prompt injection risk, stuff like that, so it's not possible to directly access information on the server. So this is a very crucial thing. So you have to think about those risks. So and in the morning, basically cloud downloads stuff from internet from the staging server and runs the analysis. So basically it looks what changed. So basically what new vulnerabilities I have, what the new problems in infrastructure, what problems are fixed, what problems are not fixed yet. So it could do that analysis, and additionally it goes to internet, looks for newly published CVEs, which is quite a lot today, and maps them against infrastructure. So by doing analysis, it builds up a database of software version numbers, so it knows what I'm running in this infrastructure. So in the morning, usually about 8 o'clock, I get summaries, so what's bad in the infrastructure and what relevant new CVEs are for me to fix. So then I'm going to go and create Jira tickets. So I may ask Cloud to basically draft the ticket. Sometimes I do it, sometimes I do it manually. So, but usually Cloud don't have access to Jira instance to post issues there. So. Why Markdown? So more or less because of lighting. So it's text format, very easy to understand. And if it needed to be, I can read the report myself. Other than that, it's basically compresses Mesos report to very manageable size. And if you look at the token consumption and complexity of working with this information, so LLMs are pretty good there. So probably I could use some self-hosted LLM if the infrastructure is very critical. Then again, in my case, I've seen that cloud LLM is kind of okay. And it's kind of more or less vendor independent. They can add stuff like that, add additional scanners, add additional tools to it, and it's still going to work. Staging server is boundary. I can mention a bit so that the main reason is that it's a secure place where basically if you can compromise the staging server, so what you're going to get is just reports. If you're going to compromise client cloud workstation, you are not getting to the real system. So you always have to think about these kind of things. Yeah, so basically I mentioned what I'm getting. So yes, I'm getting new findings, misconfigurations, and I'm not getting, for example, that this printer has bad TLS configuration, which is kind of very irrelevant. So, but for example, I want to have information about browsable directories, for example, or Git directories exposed to web server, which are usually not very high level findings. So, guest account enabled and stuff like that, which are interesting. So if there is not SMB signing enabled, probably I don't want to see this problem so each morning. So and something like that. And for Jira tasks, more or less it would create the Jira task for you. So you can point it through some MCP server, which I'm not doing. You can ask Cloud to do browsing in Chrome browsers through Chrome plugins. So sometimes I tested it. The problem is if you point the Cloud in Jira and ask him to do it in Chrome browser, it's definitely faster to do it yourself. So it will be extremely slow in that regard. So But usually I ask to summarize findings, make proof of concept code so that it's easy for me to verify that the problem still exists, easy to verify the guy who is fixing the problem is fixed. And so basically, when creating such a Jira task, think about not just problem description, the task, or yourself include some proof of concept code so that you can test it yourself, because if you're going to wait for Mesos report, it's going to be long and you definitely it won't answer that the problem is fixed. So basically what you're going to see is that there is no such problem in the Mesos scan. Yes, and this really got disclosed with basically getting information from internet about vulnerabilities, which is relevant today. So, and this actually nowadays proofs can be useful because you see, oh, there is a problem. So even before CERT is issuing warnings, sending warnings that you have to fix something, so more or less you are getting warnings yourself. So from cost perspective, if you are not asking cloud to do analysis of full scans, so basically parsing scans with scripts and creating some intermediate formats, it's pretty cheap. So you can do it for 20 euros per month on subscription. So and still gonna have plenty of tokens left. Other thing is that you can save on monitoring tools. For example, I'm using it to buy a Mesos Expert, which is kind of more expensive Mesos version, which could do much more, a bit more stuff than standard version. Probably next year, I'm not going to bother to buy more expensive ones, so I can save on the tools because I have this tool for myself. And you can bring incrementally. So another thing, if you don't have money for Mesos, use Nmap, so just regular Nmap scan with minus capital A option, which can run safe plugins against the target. So say that you want to scan all the ports with minus P minus and produce all the output. So probably you don't even have to parse anything because this output will be pretty small and parsable by cloud or similar LLM yourself. So, and probably you can use self-hosted LLMs as well. One thing which I would like to recommend is that never run Nmap or other scans. I mentioned it before, never run into the whole infrastructure. So basically, it's easy, of course, to just make big file with your IP networks and then ask it to scan. So do it one by one. So divide the networks into manageable tasks so that each scan finishes in a couple of hours, not in days. So then it will be more productive because scans not usually, but quite often fail for some reason, and then you're not going to get full visibility in infrastructure. So takeaway, very summarizing what I was talking about. AI is very fast reading documents, so it could read text, but it still has poor decision making. So it might see the problem, it might classify it very correctly, but it might misclassify it. So things that very high risk priority is just informational finding, and vice versa. For that reason, ask, make the prompt so that it shows even informational findings to look through. So probably you could write scripts for parsing Mesos files and finding the vulnerabilities. And probably, I would say it's still a bad idea to in such setup where it parses Mesos output, do some scanning in the infrastructure. There are still some prompt injection risks. I would not do it, but technically it's possible to ask cloud to manage scanning itself and scan the infrastructure. But I'm not recommending this approach. So no, I'm kind of conservative. It's separated from infrastructure, staging servers, and stuff like that. So. Plain text files are very portable, so I don't recommend using very technical stuff, so databases, stuff like that, just text files, and you can feed it in LLM and can get information. Get your inventory of all the versions, and then you can check it against the published CVs. So if you look at recent Latvian security problems, for example, Latvia's valsts measures, so such scanning and the software automatic software inventory could more or less save you quite a lot of problems in the future. So, and keep human in the chain. So basically verify everything. So it's technically I could do this integration so that it posts Jira tasks and I don't have to do anything, but it definitely misclassify some stuff, and there might be some problems in the future. So, thank you. Questions?
How hard is it to maintain version inventory? Because developers can always ask something new, so there should be a procedure for you to add into this, remove from this. So
it's two different problems. So technically, developers have to maintain this version registry. So if you look at normal software development practices, so they have to maintain. But I'm as CSO, I don't care about this stuff. So because, as you mentioned, it's problems. So there are always problems. So do scanning. So I mentioned Mesos scan, if you, for example, using Docker containers, stuff like that, scan all the Docker containers and feed it to cloud and tell it, make the inventory for yourself. So it can go to the internet, go to CVs, and can make a nice report. So you don't have to do it manually. And this is the point. If you're going to do it manually, you're definitely going to miss something.
Okay, thank you. So you think taking some containers locally or to see or how to scan containers?
There are tools, to be honest. I don't recall the exact names because there's a bunch of tools. I'm too old to remember everything, but basically you can scan Git repositories and you can scan the actually built containers which are deployed.
So connecting to the servers and
yeah, but the thing about separation, so about staging servers, stuff like that, so definitely you don't want your cloud access, don't give cloud access to this, at least this cloud instance which is doing the security analysis, because there might be prompt injection problems there. Especially if attacker knows that you are doing such stuff, so he could plan something in input which gonna go to this pipeline and might break some stuff. So just separate. Imagine that there is prompt injection and attacker gets access to your cloud LLM environment. So if you gonna get software inventory, so it's not really a big deal. It's not still a real system. So. But how to scan and what to scan, it very depends on your infrastructure. If I would have Git repositories, I can scan Git repositories and can scan build containers, because you are building containers, pulling stuff from the internet and from everywhere. So basically, a Git repository won't have all the information